Kiddos, we'll get going here, chapter 9. It'll be, like I said, probably some jumping around in this with the journal, but definitely have them as part of your notes to move through chapters 9 and chapters 10. Be honest with you, this is a part of the year where things get pretty goofy. I don't want to say goofy, but they become difficult, probably is a good word. But I think it's essential that you take good notes and refer back to the examples in order to succeed in this chapter here. We're going to start looking at some conditional statements today, some logic that comes with it, and some geometric reasoning and proof that comes with it. Again, there's some great examples in here, and I think it would be to your benefit to make sure you're getting everything down, okay? Don't forget, every third section we take a note check, all right? So those are easy points if you stay on top of that, all right? So make sure you're in section 9.1. What page is that, kiddos? 247, is that right? Page 247? Okay. All right, kids, here we go. Guys, section 9.1 is titled Conditional Statements, and the question we need to try and answer today is, when is a conditional statement true or false? All right? How about a volunteer to read what the definition of a conditional statement is right here for me? Volunteer to read that.
A conditional statement symbolized by P
can be written as a then statement in which P is the hypothesis and Q is the conclusion. Here is an example.
I have never had somebody start reading and their voice completely change from one to the other. That was awesome. Okay? That's awesome. All right, hey, here's what I think we need to highlight, or what we need to understand. Okay? This part right here, circle this right here. All right? Back up on that. That part right there. Got P arrow Q like this. Here's how I want you to read this. Okay? Couple of ways to read this. This is read as P implies Q. All right? Another way to read that is as follows. Gosh dang it. Okay, another way to read this is the following. I want you to write this in here as the following. Write down this is the same as saying if P then Q. That's read as if P then Q. If event P happens, then Q happens. All right? An example might be something like this as a statement. So, where are my track girls at? Where are my track girls at? If it's Friday, then we practice in the
Morning.
Okay, if it's Friday, then we practice in the morning. Like that, if P, then Q. So if I say if it's Friday, P represents that it is Friday. Then I say then Q. Well, I said if it's Friday, then morning practice for track girls. Now what's the Q part, or what's the Q event in that statement? Practice in the morning. Excellent. Okay. So down here there's an example that states the following. It says if a polygon is a triangle, then the sum of the angle measures is 180 degrees. Okay. The conditional statement up here stated that P is always going to be the what, kids? Hypothesis, right? Okay. A hypothesis. And then Q is going to be my what? Conclusion. Okay. Here is an example again. It says if a polygon is a triangle. Now what I'm going to tell you is this. In any conditional statement, the word if will always exist. Okay? All right. Here's the situation. I'm going to put the word if right behind that. The hypothesis is like some kind of what's going to happen. How many of you guys have had to sit in a science class and come up with a hypothesis before you did a lab?
Every single day.
You have to come up with what you think is going to happen, and then you test that. The hypothesis is the part that you think is going to happen, and then you go through and test that and see if your hypothesis is correct, the conclusion. Okay? So I'm going to tell you this right here, kids. If you ever see this word right here, if you ever see the word if in a statement, what always comes after it? A hypothesis will come after it every single time. Every single time the hypothesis will come after the word if. Now, what do you think comes after the word then all the time?
Conclusion.
The conclusion. What did you have happen? Okay, what really happens here? Well, the conclusion here always comes after then. But the thing I'm going to tell you about the word then may not be in a statement sometimes. Okay? So when we talk about if-then statements, which word is always going to be in a statement? If or then? Which word's going to be in the statement every single time? If will always be there. Okay? If is there every single time. All right? Keep that in mind. Let's look at an exploration here, kids. Give me a second. All right. Look at exploration 1 and exploration 2. I'll get that here. Oops. Okay. Exploration 1, determining whether a statement is true or false. Okay, what I want you guys to do is this. I want you guys to read through these statements right here with a partner, and we'll come back and talk about these in a second. It says a hypothesis can either be true or false. The same is true of a conclusion. It says for a conditional statement to be true, the hypothesis and the conclusion do not necessarily have to be what?
True.
Be true. Determine whether each conditional statement is true or false. Justify your answer. Okay? I want you guys to go ahead and read through those at your tables. So take a minute and right here, read through these, and we'll determine if these statements are true or false, and we'll come up with some kind of a justification, okay? We'll come up with some kind of a justification. So right here, take about a minute or two, read through them. Now, guys, a statement's typically going to be false if you can come up with a counter example. Something that says no, because that's not necessarily the way it is. In order for something to be true, how many times does it have to be true? Not just once, but not just twice. It had better always be true. If I can prove something false just one time, then that statement is considered false from now on. Okay? Take a minute to see what you guys come up with for a conclusion here. True or false? I just want to know if you think these statements are true or false when you read through them. All right, let's talk about A. What do you guys think on A? You show of hands. What do you guys think on A? True. Okay, why do you say true?
Because if yesterday was Wednesday, then today is Thursday.
So no matter what, the day after Wednesday is always going to be what? Thursday. So that's the, yeah, we can say, you know what, that's true. Okay, so number one, I would say, you bet that's true. All right. I think that's true as well. Okay, let's talk about the next one. If an angle is acute, then it has a measure of 30 degrees. Okay, could 30 degrees be the acute angle? Yes. Absolutely, but would 30 degrees be the only angle that would be acute to make that true? No. Give me an example of an angle that would work to still satisfy that if part.
60.
5.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25,
What about 31 point? We missed 31.126.
Point.
Fine. You're just going whole numbers, eh? That was good, Link. That was good. What do you guys want to say here then?
False.
False, because I could counter example. 30 degrees is not the only example. Maybe we got a 54 degree angle. Okay? If a month has 30 days, then it has to be June.
False.
False. Can you think of other months that have 30 days in it?
February. You almost said February.
March.
Well, that was,
January.
January, February,
March.
March. You guys know the knuckle trick, don't you?
Yep.
Yeah, I don't understand.
No.
So you start on a knuckle. January is a high point, so 31 days. Next one, low. February is low. March, 1. High, you're on the knuckle. March, and then April has how many days?
30.
30. May, June 30, July 31. Come back to this knuckle. August is a high point, 31. September, 30. October, November, December. Okay? Yeah, this could be false. Because it could be April. Okay? Then the next one, I don't even understand the next one myself. It says if a number is not divisible by 2, if an even number is not divisible by 2, well, then 9 is not a perfect cube. Does one have to do with the other?
I'm really confused.
Okay? Or then it says 9 is a perfect cube. Okay? If an even number wouldn't be divisible by 2, then 9 is a perfect cube. Making sense? Doesn't, does it? Okay, so this is actually going to be, I would just say, both of those statements are what? Okay, both of those are false. Do you guys understand that if I can prove something false right here, you have some kind of a counter example here, don't you? You guys okay with that? Are even numbers divisible by 2? Okay, this would never happen. If an even number is divisible by 2, not divisible by 2, it would never happen. Okay? All right, so are we okay on that first part, determining if a statement is true or false? That's my first question. Good? All right, let's progress. Down here in exploration 2, determining whether a statement is true or false. And we'll look at some truth tables here in a little bit. Okay? Okay, we're working on the partner. It says use the points in the coordinate plane to determine whether each statement is true or false. Justify your answer. Okay? It says ABC would be a right triangle if you would connect those points. Okay, so if I would do this right here, connect your points A to B to C. If I connect A to B to C, do you get a right triangle?
Yes.
Okay, right down here I'm going vertical and then horizontal. So at angle B, what kind of an angle do you have? 90 degree angle. So in part A, is ABC a right triangle? Yes, it is. So is this statement true or false? True, because angle B would be how many degrees, kids? 90 degrees there. Okay, angle B would be 90 degrees. All right, make sure you've got that. Okay, so let's keep rolling here. We're going to be using this chart. I think they have the same chart here, don't they? Oh, good, they do. Okay? It says BCD or BDC, B to D to C is equilateral. Let's draw that out. What's equilateral mean again? All sides are equal. If you would draw B to D to C here, what do you think?
Oh, yes.
B to D to C. Does this distance right down here look the same as this distance?
No.
No, it's not. You could check the distances. You would find out they're not the same. So are you saying true or false on that? Okay, I would say false on this. Yeah, I'm going to draw a triangle BDC here quickly. Hang on a second. Triangle BDC right here. Okay. This distance down here is, I don't like this. I'm going to calibrate it again. Hang on. Okay, BDC right here. Who's got a calculator handy for me? Who's got a calculator handy for me?
Braden Travas does.
Okay.
Braden, turn those on.
All right, right here, kids. Help me count the distance down below here. 1, 2, 3, 4, 6, 7. You guys agree this distance is 8 down here?
Yep.
Okay. Let's figure out some distances on here. Okay. Let's see. This is 4 squared. What's 4 squared, kids? 16. And then the height of this is 5. So my change from C to D is a change of 4 and change of 5. What's 5 squared?
25.
Okay, so this distance would be the square root of 16 plus 25, which is 41. Somebody run that number for me. Square root of 41.
Braden, can you run that?
Nearest tenth. Square root of 41.
16.
Somebody run it for me. No.
Hold on.
Six 6.4. I'm going to tell you this right over here would be the same thing. You would have a change of 4 and a change of 5 here. So this would be the square root of 41, which is 6.4. So to answer these first two questions, B and C, is that an equilateral triangle? Are all 3 sides equal? No, they're different. Okay, so the answer to this, tell this statement, this is a triangle? Absolutely not. This is false. Okay, it says BDC, the one that I have drawn up there, they say that that is an isosceles triangle.
True.
Why is that true?
Because plus sign.
Maybe I should ask this question, Keegan. What's the definition of an isosceles triangle?
Then when two sides
Two sides are
the same.
the same. Yep, so we've got 2 equal sides right here. So it is. Okay, so that's that for B and C. I'm going to redraw part D and E up here. So let's do that quickly. Okay, this time we're drawing A, B, C, D. You guys don't really need to draw this, but I'm going to draw A. Whoops, wrong one. Ah. There we go. A to B to C to D. Okay. Guys, when I draw that, hey, yo. When I draw that right there, does the top appear to be parallel to the bottom?
No. Yes. Okay.
Top and bottom are parallel, aren't they?
Yeah.
Yeah.
Okay, are the left side and the right side parallel?
No.
So the definition of a trapezoid would be 4-sided figure, 1 pair of parallel sides. Do I have 1 pair of parallel sides here?
Sure do.
I do. So true or false on this one? Okay. Is that quadrilateral we drew for part E? Is that a parallelogram?
Yes.
Are both pairs parallel? Are both pairs of opposite sides parallel? Top and bottom parallel, but what about the left and the right? No, so that wouldn't be a parallelogram. Okay, Braden, question?
Numbers you can see, right?
Yep,
That's
it's true.
true.
Okay. All right. So what are we saying here on part E, kids? Is this a parallelogram?
No.
Absolutely not. So this would be false right here. Okay. This would be false. All right. What type of shape is it? Trapezoid. Right? Trapezoid. All right. I like trapezoids. Cool. I have a fish named Trapezoid.
Do you really?
I do. Yep. I have a
Which
fish.
one of your daughters named that?
I have a fish named Ferocious too, though. Okay.
Which one of your kids named that?
I was gonna name one of my kids Trapezoid. Yep. I think that all their middle names should have had a shape in it. Ruby Trapezoidal Parson. That would be awesome, wouldn't it? What's your middle name? Trapezoidal. Huh? Lucy Square Parson. And Annie Circle Parson.
Wow,
Annie
yeah.
Circle Parson, Ruby Trapezoidal Parson, and Lucy Square Parson. Wouldn't that be awesome? And then Lucy'd be like, who did you name me after? I said, SpongeBob. Get it?
Star.
Square paint? Okay, let's talk here. Let's see if we can justify these. I'm not going to worry about part A too much here.
What was E?
I don't know. I don't remember what we wrote.
It was false, and it was a copy.
I'm going to come back to this. I want to move forward a little bit, all right? What's that?
So you said
That was last year she did in here.
Yes, I did.
you only have $20.
I don't have any money. If I did, I would.
Okay, let's move forward on this here, guys. We're gonna put some definitions down here, okay? Conditional statement, basically here. I want to get all these terms down. Conditional statement right here. Whoops. Conditional statement right here. It's going to be pretty much an if-then statement. Okay, it's going to be an if-then statement. All right, so you want to kind of get that down. Okay, next one right there says if-then form. So if-then form takes on this form right here. P implies Q. We kind of talked about this already for if-then form. We would say if what first?
It's Friday, then there's practice.
Okay, or in terms of P and Q, I would say this really means if P, then what?
Q.
Q. So the P part might be if today is Friday, then the Q part would be morning track practice. All right? So that's going to be what if-then form appears to look like.
You prefer to like log into the
Oh yeah.
Okay.
No, no one logged in by phone. It was off location.
Oh, that's yellow.
Last night I walked downstairs and my
No,
little
that is
sister
very
just started
possible.
roasting.
Okay, are you good there?
Yeah.
Hypothesis is the part after what?
Then.
Not then, but
If.
part after if. Okay, what's the conclusion? Part after what? Kids, what's the conclusion?
Then.
Part after. Then. Okay? What do you think the word negation means? To negate something. What's that mean? If something was true, what would the negation of that be? If something is true, what's the opposite of true?
False.
Negation just means kind of the opposite. So if I say today is Friday, the opposite or the negation of that would say today is not Friday. Okay? So what I would say is this: the negation of P, negation of event P, of an event P like this is written as, kind of looks like this. This part right here, see that little squiggly I put in front of P?
Yep.
Okay, that means negation of some event P is written as, this is written as not P. So that symbol means not P. Okay? When we talk in terms of things being true and false today, the negation of a statement that would be true would be what?
Wait, so why
Just Just listen to what I said. Listen to what I said, okay? The negation of a true statement would be what? Opposite of true. What it is? False. Okay? So keep that in mind. All right? Converse of a statement. Here's what you need to know about a converse of a statement. Okay? I'm going to kind of put these three things in order. Okay? We've been talking about conditional statements of the form if and then, or in other words, if P then Q. Okay? I'm going to apply this if then form to these down here. All right. Converse simply says this. It's a conditional statement in which you change the hypothesis and the conclusion. So if in this statement up here of if-then form, if P then Q, P is the hypothesis, Q is the conclusion, the converse is basically taking the order of these events. Anybody have a guess what they do with them? You actually end up switching it around. So the converse of a statement is to put the part Q first and then the part P second. And we'll look at some examples here in a second. Okay? Your inverse here is to do the following. Take this sentence right here and write it as if not P, then not Q. Right? And then the contrapositive will be another one. Right? The contrapositive of original if-then form is to say, if not Q, then not P. All right? This stuff right here, this set, is going to be very important to understand today. And we'll look at some examples. That's going to be very important for us today. Okay? Okay, equivalent statements. Here's the deal. Equivalent statements basically are the following. If you have two statements that match, they're either both true or both are true, or both might be false. Okay? If I make two statements and both statements are true, that's considered equivalent events or equivalent statements. If I say two statements, if I make two if-then statements and they both turn out false, those are equivalent statements. If one turns out to be true and the other turns out to be false, are they equivalent statements? No. They have to match. Okay? They'll have to match. Okay? We know what perpendicular lines are vocab-wise? Yeah. Yep, meaning false. Yeah. What's that?
Just kidding.
What did you say?
Parallel lines.
You know what they say about parallel lines? They have so much in common, it's a shame they'll never meet. Ha ha ha. Okay?
They never can touch. Oh my god.
Okay, let's move ahead. Let's talk about biconditional statements here, okay? Biconditional statement, we'll put here and then we'll look at some examples. Biconditional statement is the following. It stands for, it's a statement that uses if and only if. Okay? Get this down for now. We'll look at some more stuff involving biconditional statements in the future here. Okay, it uses the phrase if and only if.
And try again.
Okay. Next statement right here, truth value. Statements either have, if I say something, my statement is either what or what? It's either true or what? So when we talk about truth value, it's either saying something is true or it is false. Okay? All right. This is going to make or break you here in this section. What a truth table is. Okay? All right. Here's what we're going to do. This table is going to be pretty important for you. All right? This is going to be used to determine true or false statements. Make this table, please.
Quack.
Okay, this is very important. Here's the deal. You might have an event P and an event Q that says, if your statement is P then Q, does your statement turn out true or false? Okay? Here's the situation. I'm going to say something like this. In a statement, if I say something like this, if today is Friday, is today Friday? So P is true. Then tomorrow would be Saturday. If I say if today is Friday, which it is, true, then tomorrow would be Saturday, which it is, true. Okay? That statement turns out then to be a true statement. Okay, now listen to what I say here. If I would have said if today is Monday, is today Monday?
No.
If today is Monday, is that false right now, where we're at right now?
False.
That's false. But if I say this, if I say today is Monday, even though it's not, tomorrow would be then Tuesday. If it were Monday, would tomorrow be Tuesday? Yes. Okay, now I'm saying if it's Monday, it's not Monday, today's Friday, right? So if I say something that's true after that, if it were Monday, then tomorrow would be Tuesday. Even though today is not Monday, that was the false part. We still say the next day would be Tuesday, which would still technically be true. Is that statement I just gave you true or false? If today was Monday, tomorrow would be Tuesday. Okay? I say it's false because it's actually what day today? Friday, but we said since it might be Monday, next day would come through here. If you ever have a false statement imply a true statement, here's the deal. How many of you guys go to science and make a hypothesis that's wrong? But your conclusion in the end is, right, you might say my hypothesis is this, but it's wrong, but my conclusion is okay. Even though I started out with some information that's wrong, I still made it right. So if you ever have a statement that says false, true, if you have a false part implying a true part, then what type of statement do you end up with? True. Okay, I'm going to finish this up for you, all right? If you ever have a true statement to start, listen to this. If today is Friday, true that or false that right now, then tomorrow is Sunday. False. So listen to what I said. If today is Friday and tomorrow is Sunday, is there any truth to that at all? The part after if is true because it is actually Friday, but would tomorrow be Sunday? No. That would be false. The whole statement turns out false. So in a truth table, if you ever have a true imply a false, then that is a false statement. You guys squeeze this last one here. This isn't that going to make sense to you. If the two things that I say are false, then I'm actually making a, anybody have a guess? True statement.
Hold up, this is confusing.
Okay, so just have that chart down. Make sure you got that down. If you don't have that down, you're going to be in big trouble. Right? All right, I'm going to use this to look ahead here, okay? Here's the deal. If you have a true statement and a true statement, then the conditional statement is true. If it goes false to true, then what kind of statement do you have?
True.
If it starts out true and then turns false, what kind of statement do you have?
False.
If both statements you make are false, then what? It's actually a...
That doesn't make sense. Just that last part, just the last part confused me. The false.
Okay, here, I'll just do it. Okay? If today is Monday, right now,
Yeah.
that is
True.
False.
false, because it's actually what? If today is Monday, then tomorrow is,
Tuesday.
how about Wednesday?
False.
False. If today is Monday, then tomorrow is Wednesday. False. Okay?
That's two falses.
It's two falses, but this is going to turn out to be true. Think of it this way.
Oh, I understand.
When you have two double negatives typically turn into a what mathematically?
Positive.
That's how I want you to think of that. If you have two negatives like that, it turns into a,
Positive.
are you okay with that? Yay or nay?
Yeah.
That's how I want you to think of it, okay? All right, let's see if we can't move ahead here. And you guys got the table down? We're going to refer to that table a lot, so make sure you've got that, okay? All right, moving ahead. Let's get into some of those truth table statements. Okay, let's talk right here just to make sure we understand this. We understand right here, this is a conditional statement. Okay, this is a conditional statement which states, you see this symbol right here, it's read as P implies what? This is read as what? What's in parentheses there? Next page. P implies Q. It's the same as if P, then what? If P, then what?
Q.
Okay. Understand this. If I put a little symbol like this out here, this simply is the negation. So instead of saying P, this is actually read as how? What's this read as, kids? How is that read? Not P. All right. Okay, so let's look at some related conditionals. If P, then Q. The converse is given to you down here. You take Q and P and switch it around. Okay, so everything you need to know about converse, contrapositive, inverse, it'll all be right down here. Okay, we've already talked about those. We wrote those down. All right. I want to see if we can get some truth tables. We've already talked about all that stuff. So here's the deal. See if we can't use some of this logic to figure some of this stuff out. And then I think that on Monday when we get here, we'll start looking at some of the truth table stuff that comes along with this. You guys ready to roll on this stuff? All right, here we go. Don't think. All right, here's what we're going to do. It says, rewrite the conditional statement in if-then form. So in number 1, it says 13x minus 5 equals what, kids?
-18.
And then because x equals -1. Want us to write this in if-then form. This is pretty easy to do. This is basically, you're just going to go in here and say, you know what? If. You would simply say if 13x minus 5 equals -18, then what would you say after then? Well, I'll put that statement in if-then form. So I'm writing down this. If 13x minus 5 equals -18, then what?
X equals -1.
And x equals -1. Okay, what's the hypothesis to this statement? What's the hypothesis in this statement? 13x minus 5 equals -18. What's the conclusion? Okay, hypothesis comes right after if, conclusion comes right after then. Okay? Okay, this next one's a little bit more difficult. I'm going to write this down. You might say something to the effect of if the sum of interior angles is 180 degrees. That's my hypothesis. We have a shape. If the sum of the interior angles in a shape is 180 degrees, what shape must you have? Which shape has, what's that? Close. What shape would it be? What shape has all angles add up to 180 degrees? A triangle, right? Okay. I like what you said too there. Supplementary is 180. I agree with that. If the sum of the interior angles is 180 degrees, we have to say something to the effect of what's already up in here. We might say then the shape we're dealing with is the shape you're dealing with is going to be a triangle. Okay? Okay. I'd like to finish with statement 3, and then we're going to call it quits there for the day. I'll wait till you have that down. Okay, let's talk about 3. It says let P be what, kids?
Quadrilateral, A, B, C, D.
Is a rectangle. So they're saying, you know what? We have a figure that is a rectangle. It says let Q be what? The sum of the angles is 360 degrees. It says write the conditional statement, the converse, the inverse, and the contrapositive in words, and then decide whether each statement is true or false, okay? This is going to be pretty important. Let's first of all get the original statement written down. We're going to pick this up here on Monday. So the original statement, P implies Q. We're going to put this down just like this. I would say if what first, kids? If what first, kids?
If the sum of the angles matches.
Careful. We want if what first? If P. What does P represent? Read it, guys.
Quadrilateral A, B, C, D is
Okay.
rectangle.
So if quadrilateral ABCD is a what? Quadrilateral ABCD is a what? Rectangle. Then Q, right? if P, we've got that part, this statement represents P right here, what represents Q? And the sum of the angle measures is what? Okay. You winning today? Winning today? Yes, you may go to your gym locker. Thank you for asking. Yeah.
Sign out.
Remember, when are test corrections due?
Monday.
Monday. You need to show word?
Yeah.
Yes. Check your JMC, all right?
What did I get up?
Explain it. Write it and explain it. Have a good weekend, everybody. I'm good.
Get out. Get.
Oh, wow. Nick, I'm gonna get black power. Great.
Ivy. What? Hi, Lena.
Hey, Arlie.
Arlie.